So our final inductive proof exemplar, if you like, is this one here. So 5, showing that 5 is evenly divisible into 8 to the power of n minus 3 to the power of n for n greater than or equal to 1. Do let me know if you want more exemplars like this. There's a bunch more that I could do, but I think I've done a few different examples, so hopefully you've got the general idea. Just to stick a comment on the video or flick me an email if you want me to do some more. But working through this, starting off with our base case, and conveniently because of this, we know exactly what our base case is. So our base case for this particular example is going to be n equal to 1. So just substituting in here, I'm going to show that 5 is evenly divisible into 8 to the power of 1 minus 3 to the power of 1, which is the equivalent of saying, does 5 divide into 5? Yes, it does, so our base case holds. Now, we're going to move on to our inductive step. And for the inductive step, as per usual, we're just going to start off by replacing all of our n's in this expression with n plus 1, and then we need to show that it's still true that that will be divisible by 5. That'll be the end of our inductive proof. So 5 evenly divisible, 8 n plus 1 minus 3 to the power of n plus 1. Now this is a different example from all the others that I've done so far. You can do it in a similar way to how I did the others, but I'm going to do it in a slightly different way again to show you the range of techniques we can use to solve inductive proofs. So like before, I'm going to split these terms out into multiples of 8. So 8n times 8 minus 3n times 3. Okay, it's exactly the same as what I've got written there. And now I'm going to add in two equivalent terms but with opposite signs. So this is the same as adding 0 to our term. And the particular term I'm going to choose, and you'll see why in a moment, is 3 times 8 to the power of n. Okay, so I'm going to say 8n times 8 minus minus 3 times 8 to the power of n plus 3 times 8 to the power of n minus 3 to the power of n times 3. Okay, so again, these are just oppositing each other out. But what I can do with these first two terms is I can group by like terms, and I can write that 8 to the power of n minus 8 minus 3. Okay, that's our first two simplified. The second term, taking out the common factors, I'm going to get 3 bracket 8 to the power of n minus 3 to the power of n. Hopefully you can see why I've chosen those particular numbers there now. It's because this one here, the difference is going to give me 5. This one here, this gives me back our original term. So, looking at this expression here first, sorry, I'll close my brackets and be neat. This term here is divisible by 5 if our original case, sorry, I'll bring the piece of paper back down so you can see it, if our original case is true. So we know this is divisible by 5, and if that multiplied by 3, that will also be divisible by 5. So we know this whole term is divisible by 5. And what we can see here is this term, that difference there, that just gives us 5. So whatever this is, it's going to be multiplied by a factor of 5, and therefore this entire term here will also be divisible by 5. And we've now shown that both of our terms are divisible by 5, and we've completed our inductive proof.